What is up? I know you miss seeing my face, so I'm back. Um, we're going to start a new section. So this is actually going to be chapter 9. We kind of skipped around a little bit since we went remote. Um, we're, if you remember, right before spring break, we graphed quadratic functions. All right. The last section we did, we were factoring polynomials and quadratic functions. What we're going to do for the remainder of the year is solving quadratic functions. So we're going to be solving them. And this first lesson is just a precursor, gets us some skills that we need to be able to solve over the next couple weeks that will take us to the end of the year. All right, so what we're going to be doing today is we're going to be breaking down radicals. Totally radical, dude. All right, so we're going to be breaking down radicals, and what we want to get them in is what's called simplest radical form. All right, first of all, what is a radical? Well, you've seen them. It looks like this. So that's a radical. And it basically means take the square root of. And what the square root means is just what times itself equals that number. All right. So your basic radicals are pretty easy if you put what's called a perfect square in there. And perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. That's a perfect square. 1's a perfect square because 1 times 1 is equal to 1. 4 is a perfect square because it's 2 times 2, 2 times itself. 9's a perfect square because it's 3 times itself, 4 times itself, 5 times itself, 6 times itself, whatever. So if you have a perfect square under a radical, it just gets you a whole number. Those are the easy ones, right? You can just plug that into your calculator and boom, it's done. Square root of 49 is 7. If I want larger numbers than that, the square root of 169 is 13. All right, we could keep going with that list. These are the perfect squares up through 10. All right, what simplest radical form is we want to break that radical down. So let's say we can pull out any perfect squares and get smaller numbers under the radical. All right, so we want to break radical down so we can pull out any perfect squares and get smaller numbers under the radical. All right, that probably doesn't make sense to you yet. Hopefully it will shortly. So this is when we have a non-perfect square under a radical. So let's say square root of 18. All right, square root of 18 is, you might realize, 4 point something. I know it's 4 point something is because it's a little bit bigger than 16. Square root of 16 is 4, but not quite 25. So that's going to be in between 4 and 5. But I'm not looking for the decimal. I'm looking for a broken down radical. So what we're going to do is we're going to take this and we're going to break it down by making a factor tree. So 18, all right, what is 18? What multiplies to get 18? Let's go with 6 and 3, all right? You could use 9 and 2. And what I do is when I do my factor tree, I'm going to cross out the number when I'm done with it. And 6 is 2 times 3. And again, I crossed out that number when I was done with it. Now, any number, if it has a pair, I'm going to circle it. Anything with a pair goes on the outside of the radical. Anything that doesn't have a pair, I shouldn't have circled that, sorry, goes inside the radical. And there's only 1 3, right? The pair, only 1 3 goes outside the radical because it had a part. All right, so that was my first example. The square root of 18 breaks down to become 3 root 2. And if you're not sure, if you're right, what you can do is just plug that and plug that into the calculator and see if it gets you a nice round, sorry, it gives you the exact same decimal. Let's try another one. Let's go with square root of 72. All right, 72. We can make a factor tree. 72 is 9 times 8. I'm done with the 72, so cross it out. 9 is 3 times 3. I'm done with that, cross it out. 8 is 4 times 2. I'm done with that, so cross it out. 4 is 2 times 2. All right, now the 3 has a pair, so I'm going to circle it, put a 3 outside. The 2 has a pair, I'm going to circle it, put the 2 outside, and these are going to end up multiplying. And this one does not have a pair. Maybe we can square it or something, put a square around it. Whatever you think is going to be easy, and that's going to go on. So I have a 3 times 2, which is 6, and 6 root 2 is my answer. All right, let's try a few more. Let's try some big numbers. Let's go with square root of 500. All right, square root of 500. Let's go with 100 times 5. All right, done with the 500, so I cross it out. 100 is 10 times 10. Cross it out, I'm done with it. Now, I could break these down further, but it already has a partner. So I can just circle it, put it outside. I can't break that down any further. So that stays under it. And this is called 10 root 5. That's how we would pronounce that. 10 root 5. J. All right, let's try another number. Let's go with 128. Square root of 128. We want to break this down. what multiplies to get 128? Let's try 4 times 32. All right, 4 times 32. I'm done with that, so cross it out. 32 is 8 times 4. Done with that, I crossed it out. All right, I already see that I have a pair there, so I know my 4 can go outside. However, 8 I can break down further. It's 4 times 2. Done with that. 4 is 2 times 2. Done with that. And then I get that, so that 2 has a partner, so I'm going to have 2 go outside. Did not have a partner for that 2, so that's going to go inside. I multiply. And I get 8 root 2. You can get 2 if you have more than one that doesn't have a partner, then you'll multiply those inside. So let's say I have let's go with square root of 56. All right, 56. 28 times 2. Done with that, cross it out. 28. 14 times 2. I already see a partner. I know I'm going to have a 2 outside. 14 is 7 times 2. Can't break. These are all broken down as far as you can. Doesn't have a partner. Doesn't have a partner. 2 on the outside. 7 times 2 on the inside. Root 14 is our answer. All right. Do the attached worksheet. That'll be due on our next class, where we will actually start solving quadratic functions. G, U. All right. Have a wonderful day, and see you next time.